Hello, everyone. I would like to introduce Quanta, our first programmable chassis switches. Before I go over our solutions, I would like to share our technology milestone that we achieved and our technology roadmap we will have. So we built our first chassis switch about 4 years ago, and we put 12 switch silicon inside the chassis that make a lot of complexity on the fabric, connectivity, and the software complexity. And about 3 years ago, we built our first programmability through the SDK based on Broadcom Trident 3. This is programmable, but the switch capacity is limited to the 3.2 T. 2 years ago, we start to focus on telecom market. We built our first edge router for the data center interconnections. And we also, 2 years ago, we built our first 12.8 T of switches and our first 400 gig switches. It is good on the speed, but it is not programmable. And this year, our main goal is to build our programmable chassis and the single silicon inside of chassis switches based on Broadcom Trident 4. And this is our current product offering from QCT by different generation of silicon, different speed, from 10 gig, 25 gig, up to 400 gig. And from top of rack switches to the spine switch, from pizza box to the chassis 6RU. This is a typical application scenario on the data center for the 25 gig interconnection between server and top of rack switches. And the fabric is 100 gig. This is our new product that we keep the system in a single chip and the chassis and the data and the programmable data plane. Okay. So this one is also demo in our demo zone. And this is a 4RU line card base, and which can provide 128 port 1 gig switches. So this platform that actually can carry 2 generations of switches from Broadcom. It's either Broadcom Tomahawk 3 or Trident 4, based on the same footprint of the package and the same bandwidth. So it can provide seamless migrations from Tomahawk 3 to Trident 4. And the redundant power, redundant fan. Okay. And this is the look and the feel. I think you can see the real product outside. Okay. And the modular design of line card, we have 2 types of line card. The first one will be the 32 port per each line card, QT28, 1 gig base. The second type will be the 8 port of the 400 gig line cards. This is the interior design, 1 single chip switch mac inside, and the 4 line card for the front port. And then this is all I have today, but I think we have more time. So let's welcome Pete from Broadcom to give us more detail about the Trident 4. Okay.
Hey, thank you, Paul. And thanks to QCT for inviting us here today. QCT has been an excellent partner for Broadcom over the years, an early adopter of many of our switch product families, and we're very happy to continue working with them on their new switch based on the Trident 4 architecture. So I'll start the presentation today providing a brief overview of the networking and storage connectivity offered by Broadcom, and then focus on the switches, and in particular Trident 4 that's being used in this new platform. So I'm sure most of you are familiar with Broadcom in some respect. Most people really aren't familiar with the breadth of product offerings that we have. So on the storage side, we have controllers for SSDs, for hard disks. We have fiber channel switches and host bus adapters, connectivity for SAS, SATA, NVMe, etc. Moving closer to the compute, we have switching for PCIe. To connect that compute to the network, we have Ethernet controllers, a variety of different controllers, both smart, very high-end controllers available. On the physical side, we have optics and physical layer products such as retimers, gearboxes, and of course, what Broadcom is probably the best known for, the Ethernet switches. Here we have products from low bandwidth, low power switches that will be used in a wiring closet through to multi-terabit switches being used by the largest MSTCs. And for each of these product lines, it's not just a single point product that we have available. So for example, on the Ethernet switching side, the group that I'm in, CSG, the core switching group, we put out about 6 to 8 switches, new switches per year. So net result is that no one can really match the breadth of expertise, the depth of product roadmap that we have available. So focusing on the switch silicon, there are 3 architectures we offer: Tomahawk, Trident, and Jericho. On the Tomahawk side, the focus here has been on bandwidth, having the highest bandwidth in a certain process node, having the highest gigabits per second per watt. The primary target initially for these was the megascale, the hyperscale data centers, but we have found also great adoption for these products in enterprise core. The Trident product family, you can view this as the other bookend of the XGS or the Strata XGS architecture. Focus here has been on programmability, deeper table scales, deeper packet buffering, and making sure we have all the features for enterprise campus, enterprise data center. The Jericho product line, the focus here has been on scalability. So this would be scalability for table scales, for packet buffering, also scalability as far as bandwidth. So the Jericho line, we have systems designed based on the silicon, anywhere from a 1RU pizza box up through a multi-chassis, multi-100 terabit per second system. So focusing now on the Strata XGS product line, again, Tomahawk, that tends to lead as far as bandwidth. The Trident product line, you can kind of consider this almost a tick-tock-like strategy, where we'll come out with a certain bandwidth level in Tomahawk, and then perhaps in a new process node, move to the same bandwidth level with the Trident product line. Again, Tomahawk focuses on being fast and lightweight, primarily L3 switching based. The Trident product line really rounds it out and has a much broader feature set and also adds programmability, flexibility. So what you've seen over the years, starting with Trident 2 up through Trident 4, in 4 years, we have a 10x increase in bandwidth, with each step along the way having additional programmability. So with Trident 2, we had programmable database profiles, so you could take the databases on chip, you can carve them up as needed for different applications. Trident 3 added reprogrammable packet processing engines. So these are programmable engines on chip that will be programmed by Broadcom. So we would respond to our customer needs. We would provide firmware that can update these devices in the field. Trident 4 takes this programmability one step further, where now the device can be programmed in a high-level language. So both the forwarding and the instrumentation behavior can be programmed in a high-level language, and using a compiler can be mapped onto the device. Now, of course, we will be providing images for our customers so they can just treat this like a fixed device, just go straight to market with that. However, we do have many customers that would like to differentiate and add their own features or have proprietary features that would add onto that. And so with that, we'd provide a full compiler toolchain and source code for the base application they can use to create their own differentiated application. So some features of Trident 4. So Trident, or Tomahawk 3, was the first chip at 12.8 terabits per second. This has the same bandwidth, and as Paul had mentioned, this also adds programmability. And what you've seen here is we've quadrupled the bandwidth of the Trident product line in less than 4 years, or less than 2 years. Also added compiler programmability and also programmable instrumentation. And one thing you found with programmable switches, I think a lot of the focus initially, a lot of the interest was on programming the forwarding behavior. But what a lot of folks noticed was that over time, there's a lot of changes, a lot of innovation happening with the instrumentation. So perhaps one of the even more important features that we've seen customers requesting is that we provide the protocol stacks for all the standard forwarding protocols and then provide the flexibility so that way they can do either in-band or streaming telemetry. This is also a scalable architecture. So initially we came out at 12.8 terabits per second. The architecture can also scale to 2 terabits per second. And this is the first chip all in 7 nanometer. So this is a monolithic 21 billion transistor chip. It's one of the highest transistor counts for any chip on the planet. Net result is with the combination of features that we have, the fact that we're in 7 nanometer with a monolithic implementation, is that this chip can enable disruptive reductions in both CapEx and OpEx for the enterprise campus and data centers. So if you look at the state of the industry today for enterprise switching, in order to achieve 12.8 terabits per second, so that 128 by 100 gigabits per second, what you'd need to get is 3 chassis or multiple chassis, and each of those chassis would have multiple OEM ASICs. In comparison, now QCT, working with Broadcom, will be offering a system that is powered by a single Trident 4 that offers superior feature sets, and it's all based on that one piece of silicon. So dramatic reductions in cost and power, dramatic improvements in density. So some highlights of the chip, as mentioned before, the scalable architecture. So the same architecture, the same features can be used throughout the campus and throughout the enterprise data center, so greatly enhancing operational efficiency. One important feature also is that we have a very comprehensive and concurrent feature set. Now, this is one thing that we feel strongly differentiates this product, because what you've seen with other programmable architectures is that they have limitations in the number of protocols that can be mapped onto the device concurrently. When we designed this device, it really was intended to be a follow-on to the Trident product line, to have that full enterprise feature set, where you could have a large set of protocols with very large tables mapped concurrently onto the device. So that way you can use it throughout the campus, throughout the data center. It's very important for customers that they don't have to have a different image deployed through 4 different applications. Again, this is compiler programmable. Instrumentation, one point I mentioned before is that we're providing both in-band and streaming telemetry. So we found that different applications and different customers like to focus on one versus the other, where they may want to have in-band instrumentation, where you insert metadata into the packet as it flows through the switch, as it flows through the network. We've seen many other applications, however, where the customer would like to collect the data on a switch, packetize that, and send that to a central collector. So what we've done here is provide best-in-class both in-band and streaming telemetry. And then following on, continuing the tradition of the Trident product line, it has industry-leading both packet buffer and database sizes. I think as Paul mentioned also, this is pin compatible with Tomahawk 3. So what we've seen is that customers can take a Tomahawk 3-based system and easily repurpose that for the enterprise market using that same high volume, that high volume hardware that already exists. So if you look at the evolution of the Trident product line, what you've seen from Trident 3 to Trident 4, again, we've quadrupled the bandwidth. Trident 3 was field upgradable, so this was programmable, but the image was provided by Broadcom. In comparison with Trident 4, we've made this customer programmable. So again, we will provide a full image for someone that just wants to take the chip, take a system to market immediately. But we do also have a full compiler toolchain and source code available that customers can use to create their own application. Both chips have a very comprehensive enterprise feature set. With the programmability offered by Trident 4, one benefit you get is you can repurpose those programmable resources for non-standard L2, L3 switching applications. So if you wanted to do DDoS protection, application load balancing, large-scale NAT, etc., those are all possible to do on Trident 4. Compared to Trident 3, also, of course, we've increased the route scale, so dramatic improvements in route scale, the size of the access control list, and a huge amount of counters and, again, instrumentation on chip. So one question we get a lot from end customers is why programmability? Why is it important? Now, we all know there's a protocol soup, a bunch of protocols that need to be implemented today, but you don't know, say, 2 to 3 years down the road, what new protocols you might want to implement. So, for example, we're seeing some interest in BR multicasting in SRv6. It hasn't become mainstream yet, but certainly many customers are considering to deploy that. We also see applications where people want to have something proprietary. It would either be a proprietary networking application, or just for security, they want to put a new tag into the packet header that is proprietary to that company. And then again, for instrumentation, one standard that we support is the in-band flow analyzer, or IFA. This is an IETF draft. So we see there's been a lot of innovation, a lot of change in how both in-band and streaming telemetry is evolving in networks. And one feature we've also added to Trident 4 is runtime programmability. So with the compile time programmability, you define the high-level pragmas, the high-level frameworks for the device. However, it's impossible for you to know when the system is first deployed in the network exactly what functionality, what anomalies you might see long term. So what we've enabled is runtime changes where you can affect how the packets are traced, how they're dropped. You can affect the load balancing, the monitoring, etc. There are many features that you can change on the fly while the device is in operation. So the benefit here is that you don't have to wait for your upgrade cycles for the switch firmware. I mean, on the fly, with no loss of packets, in a live network, you can now change the device telemetry. You can now dramatically affect the device behavior. So you also have much more flexibility in the device. So the summary is Trident 4, and it really enables enterprise networks to leverage leading-edge merchant silicon. What we've seen is that the enterprise is really the last bastion for OEM silicon. We've seen that for hyperscale data centers, for telcos, that they move to merchant silicon, they move to white boxes. That's not the case for enterprises. Enterprises are still dominated by OEM silicon. Here, with this very rich feature set, the fact that you can have a 128 by 100 gig box with one single piece of silicon really allows our partners such as QCT to compete effectively against that OEM silicon and offer these dramatic reductions in OpEx and CapEx. And really this is enabled through this groundbreaking combination of bandwidth, the extreme flexibility both in compiler time and in runtime, this very rich concurrent feature set, the large table scales, and programmable instrumentation. Okay, thank you.